So in this question, you're asked to prove that R1 plus R2 plus R3 minus R is equal to 4 times capital R. So how do we try to do this? Let us start with our LHS and see whether it leads to RHS. So I'll substitute the basic formulas for these expressions, these terms. R1 is delta by S minus A plus delta by S minus B plus delta by S minus C minus delta by S. That is equal to, so now if you take delta as common, you have 1 by S minus A plus 1 by S minus B plus 1 by S minus C minus 1 by S. Now, so if you try to simplify all the 4 terms at once, it will be a hectic task because you have 4 terms. You need to take LCM of all the 4 terms. So first what I do is I'll club two terms. So let us club these 2 terms. So what is 1 by S minus A plus 1 by S minus B? If you take the LCM, you get S minus A times S minus B. And in the numerator, you have S minus B plus S minus A, that is 2S minus of A plus B. Plus, what is the sum of these two? S times S minus C. So S minus of S minus C. That is equal to delta times 2S is A plus B plus C. Minus of A plus B is C by S minus A times S minus B. Plus S minus of S minus C, S and S gets cancelled. So you get again C by S times S minus C. So this C can be taken as common. So you get C delta times 1 by S minus A times S minus B plus 1 by S times S minus C. Now let us take LCM and see what happens. That is equal to delta times C times the denominator. The LCM is S into S minus A into S minus B into S minus C. And if you take the LCM, you get S times S minus C minus plus S minus A times S minus B. So the denominator is delta square, right? The denominator is delta square. You get C by delta times. So let us try to simplify this. S square plus S square, you have 2S square minus CS minus AS minus BS. That is minus of A plus B plus C times S plus AB. So these are the terms that you have. And A plus B plus C is nothing but 2S. So you get 2S square minus 2S square. These 2 terms are getting cancelled. So you're getting ABC by delta. And I can write as into 4 by 4. And ABC by 4 delta is nothing but capital R. So you get 4 times capital R, which is the RHS. So in this question, you're asked to prove that cos A plus cos B plus cos C is equal to 1 plus small r by capital R. So first remember the formulas for small r. You have small r as 4r sin A by 2 sin B by 2 sin C by 2, right? So in the LHS, in the RHS, you have 1 plus 4r sin A by 2 sin B by 2 sin C by 2 by r and r gets cancelled. So effectively it is 1 plus 4 sin A by 2 sin B by 2 sin C by 2. And once you see the LHS and the RHS, do you see some relation between them? So I can see the relation in the topic of conditional identities. So we know that A plus B plus C is equal to 180 degrees because we are dealing with triangles. So A plus B plus C is equal to 180 degrees. This implies cos A plus cos B plus cos C is equal to 1 plus 4 sin A by 2 sin B by 2 sin C by 2. We have derived this, the topic of conditional identities. So I just use this formula here. So that is equal to 1 plus, I'll multiply and divide the second term with capital R. 4r sin A by 2 sin B by 2 sin C by 2 by capital R. That is equal to 1 plus 4r sin A by 2 sin B by 2 sin C by 2 is small r by capital R. So cos A plus cos B plus cos C is 1 plus small r by capital R. Hence, the proposition is proved. So in this question, you're asked to prove that A cos A plus B cos B plus C cos C by A plus B plus C is small r by capital R. So as we have seen in the previous question, small r by capital R is nothing but 4 sine A by 2 sine B by 2 sine C by 2. So if I can prove that the LHS is also the same expression, then my statement is proved. So to do that, what I do is I'll use my sine rule first in the numerator. So A can be written as 2r sine A, B can be written as 2r sine B, C can be written as 2r sine C. So you get 2r sine A cos A plus 2r sine B cos B plus 2r sine C cos C divided by, the denominator also you have 2r sine A plus 2r sine B plus 2r sine C in brackets. Now if you have an r in the numerator and also in the denominator, it gets cancelled out. So r can be cancelled out. Now 2 sine A cos A is sine 2A. So you have sine 2A plus sine 2B plus sine 2C divided by 2 times sine A plus sine B plus sine C. Again, remember the conditional identities that we have derived. So this is equal to, so sine 2A plus sine 2B plus sine 2C, in the denominator you have sine A plus sine B plus sine C. Just try to remember the conditional identities that we have derived. If A plus B plus C is equal to 180 degrees, sine 2A plus sine 2B plus sine 2C is 4 sine A sine B sine C divided by 2 times sine A plus sine B plus sine C we have derived in the conditional identities, that is equal to 4 times cos A by 2 cos B by 2 cos C by 2. So you can very easily derive this using the transformation formulas. So that is equal to 4 and 4 gets cancelled. So sine A is 2 sine A by 2 cos A by 2 into 2 sine B by 2 cos B by 2 into 2 sine C by 2 cos C by 2 divided by 2 times cos A by 2 cos B by 2 cos C by 2. So cos A by 2 cos B by 2 cos C by 2 gets cancelled. So 1 2 gets cancelled. So you have 2 2's remaining, that is 4 sine A by 2 sine B by 2 sine C by 2, which is equal to small r by capital R. Hence the proposition is proved. So in this question, you're given that R1 is less than R2 is less than R3. If this is so, find the order of the sides of the triangle. Second, this can be very easily done using the basic formula. So R1 is nothing but delta by S minus A is less than delta by S minus B is less than delta by S minus C. So all the quantities are positive. So if I reciprocate all this, the signs of the inequality reverses and delta can be cancelled out on all the sides. So S minus A is greater than S minus B is greater than S minus C. So minus A is greater than minus B is greater than minus C. So if I again multiply it with a minus, so again the sign reverses. So A is less than B is less than C. So if R1 is less than R2 is less than R3, correspondingly A will be less than B will be less than C. So this will be the answer to this question. So in this question, given that the sides of the triangle are 18, 24 and 30, we are asked to find the value of in radius. So again, a very straightforward question. We know that in radius is nothing but delta by S. Delta is the area, S is the semi-perimeter. And delta in turn can be found using Heron's formula if you have all three sides. So delta is equal to root of S times S minus A into S minus B into S minus C. And S is nothing but the semi-perimeter, that is 18 plus 24 plus 30 by 2. So that is 72 by 2 is 36. So S is 36. So delta is root of 36 into 36 minus 18 is 18 into 36 minus 24 is 12 into 36 minus 30 is 6. That is equal to, so 36 comes out as 6. So this is 6 into 2. So we have 2 6s. 1 more 6 comes out, into 18 2s are 36, 1 more 6 comes out, that is equal to 216. So delta is equal to 216, or 6 into 6 into 6. So the value of small r is equal to delta, which is 6 into 6 into 6 divided by s is a semi-perimeter, which is 36. So 2 6's gets cancelled. So 6 units is the right answer to this question. So in this question, you're given that a minus b times s minus c is equal to b minus c times s minus a. And if that is so, you're asked to prove that R1, R2, R3 are in AP. So let us see how we can simplify this. So a minus b by s minus a is equal to b minus c by s minus c. Right? Now let us try to simplify these terms a minus b and b minus c. So now how can I write a minus b as? A minus b can be written as s minus b minus of s minus a. So let us see whether this is valid or not. What is s minus b minus of s minus a? S is getting cancelled, s and minuses gets cancelled. So minus b plus a is nothing but a minus b. So a minus b can be written as s minus b minus of s minus a. Similarly, b minus c can be written as s minus c minus of s minus b. So these are the two simplifications that I am going to use in this question. So this implies a minus b can be written as s minus b minus of s minus a by s minus a is equal to s minus c minus of s minus b divided by s minus c. That is equal to s minus b by s minus a. S minus b by s minus a. What is s minus b by s minus a? Delta 2 is equal to, R2 is equal to delta by s minus b. R1 is equal to delta by s minus a. So s minus b by s minus a can be written as R1 by R2. So can you see this? R1 by R2 is denominator, you get s minus a, in the numerator you get s minus b. So s minus b by s minus a can be written as R1 by R2 minus 1 is equal to s minus c by s minus c is 1 minus s minus b by s minus c can be written as R3 by R2. So this implies so if R3 by R2 comes on this side, R1 by R2 plus R3 by R2 is equal to 1 plus 1 is 2. This implies R1 plus R3 is equal to 2R2. This implies R1, R2 and R3 are in arithmetic progression. So in this question, the critical thing that you need to see is this simplification. A minus b can be written as s minus b times s minus a. B minus c can be written as s minus c minus of s minus b. So if we can think of this manipulation, then the remaining question is quite easy.